Good day, everyone. Welcome to another episode of my YouTube lesson. In today's video, we are going to be looking at some problem under mechanical energy, that is machine. Whereby we are going to be looking at the how we can tackle some question that involve the velocity ratio, the mechanical advantage, and the efficiency of the machine. So we have a question here. The question goes like this: a machine of velocity ratio 5 requires 1000 joules of work to raise a load of 450 Newton through a vertical distance of 2 meters. The next we should calculate the efficiency and the mechanical advantage of the machine. So, like I always say, first thing we have to do when we want to tackle any question, either WAEC or JAM question, we need to first write what we are given down. So let's copy our given data. So we are given velocity ratio to be equal to 5. Velocity ratio is 5. We are also given require 1000 joules of work to rise a load. So we have the effort that you want to use to rise a load is mentioned in joules. That means the work done by the effort. The work done by the effort is 1000 joules. It's 1000 joules. So let's say a load of 450 Newton. So we have the load of 450 Newton. So we write it load of 450 Newton. Load is mentioned in Newton. Through a vertical distance of 2 meters. So that load move through a vertical distance like this, through a vertical distance, through 2 meters. That is distance equal to 2 meters. So they say we should calculate the efficiency in percentage, efficiency of a machine, and also we are also finding the mechanical advantage of the machine. So these are the parameters that we are given. So for the first question, we are asked to calculate the efficiency, and we only have two formulas that we can use to calculate the efficiency. We have the efficiency mechanical advantage upon velocity ratio divided by 100 upon 1. We can use this one if the parameter we are given goes with this formula. Also, we can also use the efficiency to be equal to work done by the load upon work done by the effort divided by 100 over 1, because efficiency is measured in percentage. So these are the two formulas that we can use to calculate the efficiency. So we now check it whether it correlates with the parameters that we are given. So if you look at it, from this parameter we didn't have mechanical advantage because the mechanical advantage is unknown here. So that means we cannot use this one. So we go with this. So now we're going to have our efficiency for the question 1. Efficiency will be equal to work done by the load upon work done by the effort multiplied by 100 upon 1. So we are solving for the efficiency. Efficiency will be our unknown. Work done by the load we are not given, but we are given load and the distance done by the load. So and the work done, that from our basic knowledge, work done is first time distance. So work done by the load is still going to be load multiplied by the distance moved by the load. Distance moved by the load upon work done by the effort multiplied by 100 upon 1. So now we input our parameters that we are given. We are given load to be 450 and we are given distance to be 2. This one, the work done by the effort is 1000 joules multiplied by 100 upon 1. So if you multiply everything together, so we are going to have 90% efficiency. This is for the first Roman figure 1. The efficiency they ask us to calculate. Say we should calculate the efficiency. So this is what we are going to what will the efficiency? So for the second question, which is figure 2, the second to find the mechanical advantage. So since we are getting the efficiency, efficiency can be now be equal to mechanical advantage velocity ratio multiplied by 100 upon 1. So we are going to make the mechanical advantage as with the formula. So you can cross multiply like this to be equal to efficiency multiplied by with velocity ratio. So divide the both side by 100. 100. So this one will cancel this one. So the mechanical advantage will now be equal the efficiency multiplied by the velocity ratio upon 100. So what's our efficiency? Our efficiency is 90. The one we have gotten before. This 90. Our velocity ratio from the question. Our velocity ratio from the question is 5. Our velocity ratio from the question is 5. So we input our velocity ratio. Velocity ratio is 5 upon 100. So it's going to be 900 divided by 5 divided by 100.